In this question, we're going to be answering a word problem using logarithms. The number of bacteria in a petri dish increases by a factor of 10 every day. So what that means is if we have 2 today, we'll have 20 tomorrow, and then 200 the next day, and 2,000 the next day, etc., etc. Well, there are 55 bacteria at noon on Sunday. We're curious, when will there be 20,000 bacteria? And we'd like to know a day and a time of day, rounded to the nearest minute. Well, we're going to use the formula A equals P times B to the N, where A is the final amount and P is the initial amount, and B is the base of the exponent. Now, in this case, the base of the exponent will be 10 because we're multiplying by 10. N refers to the number of times that the base is multiplied. So in other words, in this case, it's the number of days because the question tells us that we multiply by a factor of 10 every day. Okay? So moving here to the next slide, we write out the equation as we've said. And we want to isolate n, and in a question like this, where n is in the exponent, that tells us we're going to eventually use logarithms. But the first thing we want to do is divide both sides by 55. So we've got 20,000 over 55 is equal to 10 to the exponent n. Now, from the definition of logarithms, we know that we can rearrange this expression, put the exponent by itself, the base of the exponent becomes the base of the logarithm, and we can write it this way: n equals log base 10 of 20,000 over 55. Well, the log base 10 of something is the same as just the log of something. That log button on your calculator with no base is log base 10. So using that button, we see that n will therefore be approximately 2.5606673. So we'll round that to 2.56067. And you might be curious why I use so many decimal places. Well, the question is asking us to round to the nearest minute. There are 1,440 minutes in a day, so we should be using at least 4 decimal places to round to the nearest minute. And when you're uncertain how many decimal places to use many just to be safe. So when we see that we've gone 2.56067 days, what that means is we've gone 2 days, and in addition to that, we've gone 0.56067 days. Okay? So that's what it says here, 2 days plus 0.56067. Now, 0.56067 times 1440 is equal to roughly 807. You might be curious how we got 1440. Well, 1440 is equal to 24 hours in a day times 60 minutes per hour. So that's where that number comes from. So if we go 0.56067 days, then we've gone roughly 807 minutes. You know, that number of days times 1440. So the 2 in front refers to 2 complete days. This part after the decimal refers to 807 minutes. So we're talking really about 2 days and 807 minutes here. Now, we started at noon on Sunday. Well, 2 days after noon on Sunday is noon on Tuesday. So what we really want to figure out is what time is 807 minutes after noon on Tuesday. Okay? So yeah, we want to know 2 days and 807 minutes after noon on Sunday, which is the same as saying 807 minutes after noon on Tuesday. Well, we know that there are 60 minutes in an hour. If we try to evaluate 807 divided by 60 in our calculator, 807 divided by 60 is equal to 13.45. So what we're talking about here is 13 complete hours and 0.45 of an hour. A better way to express that is in using a mixed fraction. 807 divided by 60 is 13 and 27 sixtieths. And what we're saying here, therefore, is 13 complete hours and 27 60ths of an hour. Well, what's a 60th of an hour? That's called a minute. So we're saying 13 full hours and 27 60ths of an hour, which is like saying 13 hours and 27 minutes. So now we're basically saying what time is 13 hours and 27 minutes after noon on Tuesday? Well, we know that 12 hours after noon on a Tuesday is 12 o'clock a.m., in other words, midnight Wednesday morning. So we really want to know what time is 1 hour 27 minutes after midnight Wednesday morning, and that is 1:27 a.m. on Wednesday. So that, rounded to the nearest minute, is when we will have 20,000 bacteria. And we'll do that other question in a later video.